Well, dear students, actually, due to cold, I could not prepare the videos. Now I start it here. Till now, I have told you about standing wave. I derived the equation of standing wave when boundaries were rigid, when boundaries were free, and now I am trying to explain you some questions based on standing wave, and then we will take the vibration of bound medium like air column and stretch wire. So here on the board there is a question: progressive wave is given by y equal to 0.08 sine 2 pi bracket t 200 t minus x centimeter. This wave is a traveling wave, is reflected from rigid boundary, and after reflection amplitude reduced to half of original value. To find the equation of reflected wave, if the wave be reflected from free boundary, then what is the equation of reflected wave? So you know, when wave is reflected from free, if equation y equal to a sine 2 pi t upon t minus x upon lambda is reflected from rigid boundary, there occurs a change of phase of pi radian, and we can write it is a sine 2 pi t upon t plus x upon lambda or plus pi. This is the equation of reflected wave when we assume that there is no loss of energy, or this y dash will be minus a sine 2 pi t upon t plus x upon lambda. This plus indicates here that wave travels in negative x direction. Here this wave traveling in positive x direction. So here we are given equation is this: amplitude reduced to half. If y equal to 0.08 sine 2 pi 200 t minus x centimeter is reflected from rigid boundary, then an amplitude reduced to and amplitude is reduced to 0.04 centimeter. The reflected y dash will be 0.02 sine minus पे आएगा यहाँ, because from rigid boundary there occurs change of phase of pi minus this sign. So y equal to minus 0.04 sine, but and rest does not change 2 pi 200 t plus x upon lambda. Sin 180 plus theta, you know, is equal to minus sin theta. इसलिए minus आया यहाँ पर. Now, if the boundary were free, there occurs no change of phase, then if boundaries are free, then y double dash 0.04, because I am reduced to half, sine 2 pi 200 t plus x centimeter. So remember, because we will use this fact, when there occurs reflection from rigid boundary, there occurs change of phase of pi radian. Now there is another question here: I hope you are getting my point. There is a question here. The equation of stationary wave is given by y equal to tan cos pi x upon 15 and cos 100 pi t, where x and y are in centimeter, y and x are in centimeter, time t in seconds. Find frequency, wavelength of original progressive wave and equations of the original progressive wave. In my video I have told you when this equation comes. If I take initial wave as the wave traveling positive direction, y equal to a cos 2 pi x upon 2 pi t upon t minus x upon lambda, and this wave reflected from free boundary, there can no change of phase, then reflected wave will be a cos 2 pi t upon t plus x upon lambda. And if y and y dash superimpose, then cos c plus cos d. So this indicates that this wave is formed here in a medium whose boundaries are free. Here this wave is formed in a bound medium whose boundaries at the two ends are free. In that case, cos c plus cos d. So if they superimpose, supposedly y1, y2, sorry, yes I did that. So y will be y1 plus y2. So it will be 2a cos c plus d by 2. So 2a cos 2 pi t upon t or cos minus 2 pi x upon lambda. But you know cos minus theta is equal to cos theta. So 2a cos 2 pi x upon lambda or cos 2 pi t upon t. I am just revising the topic taught in last video. If boundary were rigid, then what had been the difference? A cos 2 pi t upon t plus pi cos 180 plus theta again minus cos theta. Then cos c minus cos d. Then here equation will come out as 2 sin 2 pi x upon lambda sin 2 pi t upon t. I have explained this. So comparing this with this equation, आपसे पूछा गया है कि what are the frequency and wavelength of the original progressive wave and equation of the original progressive waves. So if I compare it here, 2a equal to 10. So this is compared with this. 2a equal to 5 centimeter. 2 pi upon lambda is equal to pi upon 15. So lambda is equal to 30 centimeter. 2 pi upon capital T. 2 pi upon capital T is equal to 100 pi t, 100 pi. So 1 upon t is equal to 50, यानी कि frequency 50 hertz. You know 1 upon t equal to frequency. So wavelength 30 centimeter, frequency 50 centimeter, amplitude of the wave, initial wave 5 centimeter. Now you are asked equation of initial waves. हमारे initial wave ये होंगी. तो क्या बनाएगा equation? y1 equal to a 5 cos 2 pi 50t or minus x upon 30, and y2 will be 5 cos 2 pi t 50t plus x upon 30. I hope you will enjoy this question. Actually, chapter of wave motion is taught in the last in class 11, and the student remain in trouble, I have noticed. But this is a simple chapter if learned properly. So this was the equation here, dear students. Now one more question here on standing wave. Simply I am using the equation of standing wave. I am telling you how to obtain the question relating standing waves. Here he says one question is there. Component waves producing stationary waves have amplitude, frequency, velocity A equal to 8 centimeter and frequency and 30 hertz and velocity V equal to 180 centimeter per second. To write the equation of stationary wave, component waves, दो वेव होंगे जिनके एम्पलीट्यूड फ्रीक्वेंसी वेलोसिटी है. तो फर्स्ट ऑफ ऑल तो वी नीड द वेव्स, कंपोनेंट वेव वी नीड. तो लैम्डा वी बाई एन, बिकॉज वी नीड लैम्डा 180 अपॉन 30 6 सेंटीमीटर. So equation, suppose I take here that boundaries are free, then y1 is equal to a, actually equation हमारा sin 2 pi, I keep this है ना, तो y1 होगा हमारा एम्पलीट्यूड 8 sin 2 pi 1 upon t 30t और minus x upon 6. So this is the equation of wave traveling in positive x direction. Standing wave is formed when two waves travel in positive direction. So y2 8 sin 2 pi 30t plus x by 6. Assuming here that boundaries are free, then equation of standing wave y equal to y1 plus y2. y1 plus y2 8 sin 2 pi 30t minus x upon 6 और plus 8 sin 2 pi 30t plus x by 6. तो it is sin c plus sin d. तो 2 sin c plus d by 2 cos 2c minus d by 2. So 2 8 जा 16 sin c plus d. तो x by 6 term cancel. So it will be sin 2 pi into 30t और cos c minus d. तो cos it will be minus 2 pi x upon 6, but cos minus theta cos theta, so it will be 16 cos 2 pi x upon 6 और sin 60 pi t. This is the equation of standing wave here. This is the equation of standing wave. pi take माना boundaries are free. ठीक है भाई? So you can write like this, or you can cancel this 2 3 r. Now there is one more question here. The vibration of string of length 1 meter fixed at both ends. पढ़ेंगे हम इसको तो अल्टीमेटली इक्वेशन ऑफ स्टैंडिंग वेव है y इक्वल टू a tan sin pi x upon 30 और cos 100 pi t. This is the equation of standing wave in a stretch string. So you are asked here x, y are in centimeter and t in second. Maximum displacement at 5 centimeter. यानी कि maximum displacement at 5 centimeter. What do you mean by this? Maximum displacement is called amplitude. And here maximum displacement is called amplitude. And you know here amplitude is A. So A is equal to tan sin pi x upon 30 है. This is here amplitude. So you are asked maximum. I told you that when stationary wave is formed, there are certain points where amplitude is maximum. Called with those points are called antinode, and there are certain points where particle or medium do not oscillate at all. That is called, those points are called nodes. And in between node and antinode, amplitude of vibration varies. In stationary wave, amplitude of vibration is different. Amplitude of wave means maximum displacement. So at 5 centimeter जाएगा. तो A at 5 centimeter given by A is equal to tan sin pi into 5 upon 30. So it is tan sin pi by 6. Pi by 6 means 30. Tan sin 30. Sin 30 1 by 2. So tan into 1 by 2 यानी कि 5 centimeter. भाई maximum amplitude तो हमारा we can't say 10. 10 कहाँ होगा? At x equal to lambda by 4, like that, है ना? फिर 10 रहेगा. But at 5 centimeter is 5 centimeter. Okay. And distance between successive nodes. So distance between successive node means or two nearest node is lambda by 2. So comparing it with y equal to 2a sin 2 pi x upon lambda or cos 2 pi t, we get 2 pi upon lambda is equal to pi by 30. Cancel. So lambda is equal to 60 centimeter. 60 centimeter wavelength, but distance between nearby node half of wavelength. So distance between nearby nodes, hence distance between nearby nodes lambda by 2 is equal to 60 upon 2, 30 centimeter. So please see these questions carefully and try to understand, because in every exam there is a question on standing wave in different form. Okay. Now if you like video, please like, subscribe the channel if you have not, and ask your friend to subscribe the channel. Thank you.